Hey everyone, now that we worked on multiplying and dividing fractions, we can move to mixed numbers and then more order of operations stuff. So the method to multiplying and dividing mixed numbers is simply just to convert each mixed number to improper form and then multiply and divide like normal. So it's actually if you're comfortable multiplying, dividing fractions, it's a pretty easy concept. We have 3 1/3 times 5/8, for example. And remember, 3 1/3 means 3 wholes plus an additional 1/3. So like there's an understood plus in there. So first what we're going to do is convert this. So 3 1/2 becomes 3 wholes is 3 times 3, 9 9/3, plus 1 more third, that's 10/3. Times 5/8. So now that I've got that 3 1/3 converted, I can just go ahead and multiply. So let's write this as 10 times 5 over 3 times 8. And are there any factors in common? Usually, we look at these 10 and 8 and 3 and 5. So any factors in common between 10 and 8? Indeed, there's a 2. So I'll write 10 as 2 times 5, and then there's another times 5. And then in the denominator, I have 3 times 8, which could be written as 2 times 4. And of course, now we will identify our common factors. Divide by 2, divide by 2. And what I'm left with is 25 in the numerator and 12 in the denominator. 25 twelfths. So now, of course, this is an answer to your question. However, it would be strange, since the problem was given to us in mixed format, to give our answer in improper format. So what I'd like to do is to now convert back. And this isn't always necessary. Now let's convert back to mixed form. And in order to convert to mixed, we basically just do long division. 25 divided by 12. 12 goes into 25 twice. 2 times 12 is 24, with a remainder of 1. So this could be also written as 2 wholes with a remainder of 1 over 12. All right, let's do another one. So again, just reviewing. First thing we did, first convert to mixed. Or sorry, not to mixed. From mixed to improper. That's what we did here. First convert to improper form, and then just multiply. And then if the problem calls for it, we'll convert back to mixed form. All right, let's do another problem. Now let's work on division. 2 1/2 divided by 1 1/4. So first we'll convert to improper. So 2 1/2, 2 times 2 is 4, plus 1 is 5. So 2 1/2 is the same as 5/2, divided by 1 1/4. 4 times 1 is 4, plus 1 is 5. So that's 5/4. All right, and now we have to remember that to divide with fractions, we take 5/2, multiply by the reciprocal of the second number, 4 over 5. All right, and I do already see that factor of 5 in common. Let me just rewrite it one more time. 5 times 4 over 2 times 5. So factor of 5 in the numerator, factor of 5 in the denominator. So I can go ahead and divide those out. And now also, there's a factor of 2 in the denominator, and 4 has a factor of 2 in it. So divide by 2, this gives me 1. Divide this by 2, that gives me 2. So what do I have left? It's a 2 in the numerator. And what do I have left in the denominator? Nothing except a factor of 1, which I always have. And so then I can always write this, reduce this. 2 over 1 is just 2 wholes. Okay, so great job. Again, multiplying and dividing mixed numbers. It's basically the same, one extra step. First convert it to improper form, and then proceed as we did in the last section. All right, so now that we have a lot of experience multiplying and dividing with fractions, let's just do a review of order of operations. And now we're considering this fraction bar here as a grouping symbol. So that's kind of all the way up there on the level of parentheses. So just to review, what order do we do computations? We start with parentheses or grouping symbols. And again, the fraction bar is considered a grouping symbol. It's going to group the numerator all together and the denominator all together. And then the very last thing we'll do is divide if we can. All right, and then we do like exponents, and later on we'll get to roots, which are inverses of each other. Then we do multiplication and division. And again, we do those from left to right because they're on the same level there. And addition and subtraction in the order that we see them from left to right. All right, so let's go ahead and see. First, I see this grouping symbol, the fraction bar. So it's going to tell me to do everything in the numerator separately from everything in the denominator. So in the numerator, first thing I'm going to do here is the multiplication that I see. Right? That comes before the subtraction. So I'll just rewrite the 4 minus 2 times 3 is 6. And in the denominator, I see an exponent. So I'm going to go ahead and do that first. 2 squared is 4, and I'll have another plus 2. All right, next step, I'm going to reevaluate. I still have this grouping symbol here, which tells me to do the numerator, denominator separately. 4 minus 6, that's like 4 plus a negative 6, right? So my answer is negative, and the difference between 4 and 6 is 2. So negative 2 over 4 plus 2 in the denominator is 6. All right. It's looking pretty good so far. Now I'll ask if this fraction can be reduced at all. Turns out that both 2 and 6 have a common factor of 2. So divide by 2, I get 1. Divide by 2, I get 3. So my answer here is negative 1 over 3. Negative 1/3. All right, so the main idea here was to treat this fraction bar like a ginormous grouping symbol. All right, let's do one more example. This is one that people typically get wrong because we see this square and here's an 8 and a 4 with a square. So people just want to like cross everything out, but that's not necessarily the case. Let's go ahead and follow the order of operations. In the numerator, so the fraction bar is separating these two things. In the numerator, I have 8 minus 4 in parentheses. I have to do that first. 8 minus 4 is 4. 4 squared over. And in the denominator, I see the exponents. I'll go ahead and do the exponents before I do that subtraction. 8 squared is 64 minus 4 squared is 16. All right, one more time. In the numerator, I have a 4 squared. That evaluates to 16. In the denominator, 64 minus 16 is 48. And now I look at 16 and 48 and ask myself if that fraction can be reduced. And indeed, they both have some factors in common. This time, I'm going to go ahead and factor. I'm going to factor the numbers. 16, maybe I'll write that as 2 times 8. And 48, maybe I'll write that as 6 times 8, because I know they both have a factor of 8 in common. So, divide by 8, divide by 8. Now I have 2/6. Now wait a minute. I think this fraction could be reduced even further. So 2 in the numerator, 6 could be written as 3 times 2. Divide by 2, divide by 2. What do I have left? It looks like there's nothing left in my numerator, but again, I know there's always an understood factor of 1. So 1 in the numerator, 3 in the denominator. So my answer is 1/3. All right, most of your homework on this section is actually more focused on these order of operations things. So remember, one step at a time, identify the first computation that you'll do and reevaluate every time.